Welcome back to the deep dive. Today, we're going to get into something I know a lot of you are thinking about. Running large language models locally. You have this powerful hardware, especially your GPU, and you're wondering how to get the most out of it. You've probably run into the big three, Ollama, vLLM, and Llama.cpp.
Yep, and they are everywhere.
They are, and our mission today is to really unpack why these frameworks are fundamentally not interchangeable. This isn't just about picking a flavor you like.
No, not at all.
Choosing the wrong one can actively, waste your hardware's potential, especially when you're moving from just playing around to actual production.
Exactly. And to understand which tool you need, you have to look past the name and get into the architecture. We need to define what each one is specialized for. Maybe we can use a metaphor before we jump into the use cases and the performance numbers.
Okay, a metaphor works. Let's start at the foundation. If we're talking about cars, Llama.cpp has to be the raw, high-performance engine block. It's that low-level engineering backbone.
That's a perfect analogy. It is the engine. It's written in pure C and C++, which is, that's the critical part.
So no extra dependencies, right?
None. No additional baggage. That gives it just exceptional efficiency and the best hybrid CPU-GPU interface out there.
Yeah.
It's built for maximum flexibility with your hardware.
So that's what makes it so accessible.
That's the key to accessible AI. It's the ideal way to run these big models on, resource-constrained devices. Your personal computer, your laptop, even your phone.
Okay, so if Llama.cpp is that bare metal engine, then Ollama is the beautifully designed, ready-to-drive car that's built right on top of it. It uses that Llama.cpp engine, but wraps it all up in a really user-friendly package, makes deployment incredibly fast.
And that's its whole advantage. It's all about time savings and developer experience. It's literally a single command installation. You can be up and running in hours.
Wow, hours.
Developers love it. It handles the models automatically, has better memory management, and this is a huge one, you can switch models on the fly without restarting the server.
Oh, that's a massive quality of life feature.
It is. It's something vLLM just completely lacks.
So it sounds like Ollama solves, 90% of a developer's daily headaches, but what's the catch? Is it just slower or is there more to it?
It's simply not built for scale. Ollama is perfect for rapid prototyping, or say, for internal tools with a handful of users. It prioritizes ease of use over extreme high throughput performance.
Okay.
And when you need that last 10%, that high concurrency enterprise level traffic, that's when the architecture has to change completely.
All right, so let's make that transition from rapid development to just sheer scale. Now we have to talk about vLLM. This shifts the focus entirely. If Ollama is the sedan, vLLM is the Formula One race car.
I like that, yes. vLLM is a specialized Python library, and its one and only job is to maximize GPU utilization when you're serving LLMs. It's brilliant at batching huge volumes of requests. And the real innovation here is a revolutionary memory management technique. It's called page detention.
Okay, hold on. Page detention. That sounds super technical. Break that down for us. Why should we care about this specific detail? What makes it so revolutionary?
Right. So think of it like this. Your GPU is constantly trying to pull data from memory to run the model. Page detention is like a brilliant librarian who only grabs the exact few pages you need right now instead of checking out the entire massive book.
Ah, so it keeps the memory free.
It keeps that expensive GPU memory free, and it just dramatically reduces the time the CPU spends waiting. That single optimization is where all that staggering speed comes from.
Okay, let's talk about that speed. The benchmarks I saw were just, well, they were insane. Something like 44 times faster.
It's a whole different order of magnitude.
Yeah.
In high concurrency tests, vLLM was consistently way ahead of Ollama, I think up to 3.23 times faster at its peak.
And against Llama.cpp?
The gap is just massive.
Yeah.
vLLM delivered more than 35 times the request throughput and over 44 times the total output tokens per second.
Let's translate throughput for everyone listening. If Llama.cpp can handle an API for, say, 10 users at once, you're saying vLLM could handle 350 users simultaneously.
Without melting down, yes.
Yeah.
It's all about maximizing how many users you can serve at once and how fast you can get them an answer.
So that confirms it. vLLM is for high-performance, enterprise-level applications. It's the only real choice when downtime means you're losing revenue.
Precisely.
Which brings us to the final verdict. How do you pick the right tool?
At the end of the day, you just have to look at your goal. If your goal is quick iteration, rapid development, you use Ollama, period.
And for production.
If your goal is maximum users, high concurrency, and revenue, you have to migrate to vLLM for production.
And what about our original engine block, Llama.cpp?
If your goal is cost efficiency and just accessible AI on the smallest hardware you have, your laptop, whatever, you stick with Llama.cpp.
So the lesson is clear. Choosing the right framework means you're not leaving performance, time, or money on the table.
And, that brings up a final thought to leave you with. vLLM's dominance right now rests almost entirely on breakthroughs like paged attention.
Right.
So what if the next game-changing memory technique doesn't come from a Python library? What if it comes from the low-level Llama.cpp community, merging the speed of vLLM with the pure accessibility of C++ ML? What happens to vLLM's edge then?
That would change the entire landscape.
Yeah.
Something to think about. Thanks for joining us for this deep dive.